Hi, I'm Dirk Dusharme, and welcome to Technorazzi. We're back at CPM Labs in Rancho Cordova, California. This series of episodes was inspired by you, our viewers. You told us what you wanted to see, and we're bringing it to you. This week, all about gauge blocks. Hi, we're here again with Craig Howell of CPM Labs, and we're going to discuss today gauge blocks, which is a topic that we really should have talked about back in the first episode, because you've seen us using them, and really gauge blocks are the basis, the foundation, right, Craig, for your whole dimensional metrology system.
They're the foundation for pretty much everything we do. They're a very stable reference standard. We use them both in a reference standard situation, and we use them to set up parts on the shop floor. They can be set up a number of ways. Gauge blocks are basically made in two different shapes. You have the rectangular and the square. Earlier versions, they made a round one. That's pretty well been discontinued. The rectangular are usually preferred by metrologists. Most of the higher end inspection, they prefer the rectangular. They seem to be more stable. The square ones have a hole down the middle, which can be very handy. When you're ringing several together, you can actually insert a rod down the middle with little tightening screws to hold it still when you tip it horizontally or at an angle. The materials that come in are tool steel, which is the most common. It's a very high grade of tool steel. Chromium carbide, which Starrett has under the brand name Croblocks, and they're ceramic. Each have their own advantages and disadvantages. The tool steel is the most commonly used, and it's the least expensive of the three. The ceramic is the next level up as far as expense. They're a lot harder, they have better wear resistance. They can actually save money on the shop floor if they're used in a heavy environment. These will be worn out rubbing them together, where the ceramic will hold up longer.
Okay.
The Croblocks are the highest level of standard that Starrett Weber makes, and they go all the way back to the invention of Starrett's original gauge block. Croblocks are the most stable. They will hold their dimension longer than any other material.
And I'm assuming they're probably more expensive?
They're the most expensive.
Now you're going to show us some, I think you called it ringing, where you're taking gauge blocks and basically stacking them up on top of each other, is that right?
Yes, a lot of times to build a set length, this is used quite often when setting up a sign bar. You'll have to set it up to a certain length on one end of the sign bar. Ringing blocks is how you do it.
Now what's a sign bar?
A sign bar is used to create angles. You will set a sign bar up and you'll put a part on it that has a known angle, and you can measure another surface that now is flat. So I'll show how we prepare to ring gauge blocks together. We first clean them. We get them very, very clean and dry. Then there's a process of putting the two together and lightly sliding them across each other, and they'll adhere. They'll adhere just by their own surface finish, no adhesive of any kind. And it remains quite stable.
Okay.
I'll show you how they're cleaned. You take some isopropyl alcohol to start. And I'll clean the two surfaces we're going to be dealing with. We never touch the actual working surface of the gauge blocks. The reason I'm wearing gloves, there's two different reasons. One is thermal transfer of heat. I'm 98.6. They are 68 degrees. The other is the oils and the contaminants on our hands. A lot of people have very acidic skin. When they handle parts, you'll notice they'll rust within a few days or weeks, and also just the oils in everybody's hands. We'll take these, make sure they're very, very clean and dry.
Let me see what you're doing here.
These both should be very clean. Now I put them together, and I don't feel any grit or any sort of contaminant. I pull it off to the side, and I rotate it as I'm sliding it across with a little bit of pressure. You feel it start to adhere. It's starting to adhere already. Twist a little bit as I go, and they should start ringing together. You watch and you'll see them start. They're starting to ring, and now they have held together to the point that they will hold together. It takes quite a bit. You can even lift it by the top one. I'll attempt to ring a square gauge block and a rectangular one. It's a little more difficult. And
see what you're doing here.
As we were talking about temperature and contaminants on your hands, you'll have to get your hands off the plate.
Sorry?
Your temperature is transferring the plate, but especially the oils in your hands and the contaminants are. Now here, these two are rung together to the point that you can lift it up just by the top one. But that is how you ring the blocks together. It's very critical when you're doing it that you don't go at an angle and gouge or scratch the block. You want to stay parallel. I usually start all the way on and pull myself off, and you can feel it start to adhere, and then you twist as you go. Keep it very, very flat.
And that's why they call it ringing, because
it's wrung together. After we've wrung these together, the temperature from our hands and even the friction from moving them together will cause them to grow. So after they're wrung together, we leave them set for several hours if possible.
So you're saying, even you've just touched them really a brief amount of time, each of these maybe 15, 20 seconds, and that's enough to make them change the dimensions?
Well, that's a good point, Dirk, and I've set up a little experiment to show how temperature will affect the length of a part if it comes off the shop floor warm, or if you were to measure a gauge block stack too soon. It'll show up.
Okay, so you've set up a little experiment for us here to show what temperature does to the expansion on this gauge block, or any part actually, right?
Yes, as the temperature increases, the gauge block is going to grow, and that's pretty much what you would see with a part if it came in off the shop floor from a machine and you were to measure it while it's still warm.
Okay.
So what we've done is set up a test indicator, which is commonly used in the shop, on a gauge block in a controlled environment. It's a little warm in here because of the lights from the filming, but in a 68-degree environment, we've raised about 2 degrees. We've got the indicator set to 0 on the 4-inch gauge block. What we're going to do is heat up the gauge block to about body temperature, right around 98, 99 degrees, and see how much it grows where we can actually see it on the test indicator.
Okay, so you're telling me that as you hold this block, we're going to see the needle actually move on this?
The needle will move because the block is going to grow, and the needle will show that increase in length.
And what's the resolution of this?
This is a 50 millionth indicator.
Okay.
And it should show quite a bit of growth.
Okay, let's see what happens. Okay, so now you're going to heat this up with your hands, right?
Yes, I am.
So you're taking off your gloves.
Take off my gloves.
You're actually going to touch the gauge block, which you just told us not to touch, with your bare hands.
And now I'm going to hold it, and the needle here should respond. It should start to move. It might take almost a minute to grow. You can see by the thermometer we've raised the temperature a couple degrees, just a couple degrees, and it's grown a tenth. So that gives you an idea of if 2 degrees grows 1/10 of an inch, you can imagine with something coming off the floor at 100-degree temperature, or...
So 2 10,000ths, that's 0.0002?
Yes, it is.
So what, this has taken us, what, maybe 2 or 3 minutes of holding this. The temperature's gone from
70 to 75 roughly, about 5-degree difference, and you can see we've grown 2 10,000ths of an inch.
If this was a part that we had been handling in our hands rather than, let's say, a gauge block, we would actually, our measurement would actually be off by 2 10,000ths of an inch.
It would be at this point.
Which could be enough to show that the part was out of spec, even when maybe it was in spec.
It could be. It would be a different reading. It could be out of spec. It could show being in spec if it was small.
Okay, now you're going to show us. We're going to simulate a part maybe coming in off a warm shop floor, maybe coming right off some sort of machine tool like a milling machine,
yes,
and taken directly into the calibration lab to be measured. And now we're going to be talking differences of what kind of temperature?
Probably about 30 degrees. We're going to go up to 100 degrees,
okay, so,
which is roughly body temperature or off a machine.
So if you've taken something right off a machine, it might be 100 degrees Fahrenheit. You say, hey, I'm going to go measure this. And regardless of whether you're doing it maybe in a lab or on the shop floor, you're going to have this big 20 or 30 degree temperature differential.
Yes.
And we should see something pretty dramatic.
We should see some more growth.
Okay, so now we're, this is like as if we've just brought a part in from the shop floor, maybe right off a machine tool.
This part's right at about 95 degrees, 94.7. It looks like we've grown 8 10,000ths of an inch. We're approaching 1,000th growth.
That's huge.
Now the temperature is going to continue to drop as this block tries to get back to 68 degrees. But you can see the difference in length right here on the indicator. It's measurable. You can see the difference.
So this is definitely a problem. If this part had come in right off the shop floor into your lab, this shift of 30 degrees or so, almost like
change it almost 1,000.
Almost 1,000th of an inch.
A part could appear to be out of tolerance as it's too large, or an undersized part could appear to be right in the middle of the tolerance band when in fact it is too small.
Okay, well thanks, Craig. I guess what we've seen today is the various types of gauge blocks, how to ring them together, handling, Not putting your hands on the
Keep your
surface
hands off the plate.
And also, what an important difference temperature makes, and to be careful of handling the gauge blocks, bringing parts or materials in from the shop floor, that you have to allow everything to come up to room temperature.
Come up or come down, depending if it's too warm.
Okay. Well, I appreciate you showing that to us, and we'll see you again next week.
Thank you.
Thanks.